Hello students, in this video we are going to see some of the oxidation states that halogens will exhibit. So halogens, they have the outer electronic configuration of Ns2 Np5. Thus, these elements, they tend to gain or share one electron to attain the stable noble gas electronic configuration of Ns2 Np6. So let us understand the various oxidation states that the 17th group elements or halogens will exhibit. So we have to take help of its box representation. So let us draw the boxes. So let us fill the electrons. Now I am filling Ns2 Np5. So this, the first box representation, how I will fill this, Ns Np, I kept this d orbital empty so that if required I can excite the electrons. So let us keep this as d here. So 1, 2, students, you have to follow Hund's rule while filling the electrons. So those two I have filled. Now for filling the 5 electrons, it will be 1, 2, 3, then the pairing 4 and 5. So the hint how to find the oxidation states is that you have to count the number of unpaired electrons that it has in its orbital. Now if you see this, there is only one unpaired electron and therefore the first possible oxidation state that halogen can exhibit is +1, the other is -1. So whatever you see the number of unpaired electrons in its ground state, so both plus and minus, you have to write the oxidation state. So here it will be +1 and -1. If any halogen, it exhibits +1 or -1 oxidation state, then students, that atom in a given molecule will exhibit. Now if I write this, this will be Ns2 Np5 electronic configuration, then it will have sp3 hybridization. This is S and 3p are involved here. So it will undergo sp3 hybridization with 1, 2, 3 lone pairs. So this will be the hybridization with 3 lone pairs and therefore the expected geometry will be linear for a halogen that is having +1 or -1 oxidation state. Now students, what you have to do is you have to keep exciting one electron each time. So let us now first excite this electron from here to see the next oxidation state for halogens. So if this electron moves to this, what I will have, 1, 2, this will remain as it is. Now this will get unpaired, 1 as it is, and this electron will shift to this. So how many unpaired electrons are there now? There are 1, 2 and 3 unpaired electrons. So students, remaining oxidation states, you will write them with positive sign. So the next oxidation state will be +3. If a halogen exhibits +3 oxidation state, then it will undergo sp3 dehybridization. sp3, sorry, this will be N, dehybridization. So it will undergo, I am writing here, sp3 dehybridization. How many lone pairs, students? 1, 2. So with 2 lone pairs, and the geometry will be trigonal bipyramidal, but as there are 2 lone pairs present, the geometry will become bent T. Bent T because of the 2 lone pairs. How it will be, student? This is the regular geometry what it will have, and as there are 2 lone pairs, one at this position and the other at this equatorial position. So the 2 lone pairs will be like this and the geometry will be bent T. If you can see this, it will be bent T. Let us see the next excitation. Now in the next excitation, I will be exciting this electron from here to this. So what you will have, student? 1, 2, 1, 1, 1 and 1, 2. So it will have Ns2, Np3 and Nd2. So what will be the oxidation states here? There are 5 unpaired electrons. So the oxidation state will be +5. Halogens exhibiting +5 oxidation state in any compound will undergo sp3d2 hybridization. sp3d2 hybridization with 1 lone pair. So what is the expected geometry here is octahedral, but as there is one lone pair, therefore the geometry will be square pyramidal. How it will be, student? It will be like this. Now the one lone pair will be in the axial position in this way, and the geometry will be in this manner, that is square pyramidal. Let us see one more excitation is possible here, because there is one paired electron here. So let us bring about that excitation also. So this electron will move towards this vacant d orbital. So it will be 1, 1, 1, 1. So everywhere it will be unpaired electrons. This will be ns1, np3 and nd3. So what type of hybridization it will undergo, students? It will undergo sp3d3 hybridization. And what will be the expected oxidation state here? It will be +7. What will be the geometry here? Regular geometry will be pentagonal bipyramidal. As there is no lone pairs, the geometry will be the regular geometry. So students, what all oxidation states are possible in halogens is +1, -1, +3, +5 and +7. So halogens can exhibit +1, +3, +5, +7 and -1 oxidation states. Now students, you know that fluorine being the most electronegative element in the complete periodic table with the electronegativity of 4, it cannot exhibit any positive oxidation state, and therefore fluorine always prefers to exhibit -1 oxidation state, always. Second thing about fluorine is, as there are no d orbitals present in fluorine, therefore fluorine can exhibit only sp3, sp2 or sp type of hybridizations, but mostly it exhibits sp3 hybridization, and it will not show any hybridization where d orbitals are involved. Next very important thing about halogens is that few of the halogens like chlorine and bromine, they also exhibits +4 and +6 oxidation states in their oxides and oxyacids. Otherwise, most of the time the oxidation states, that is +1, -1, +3, +5 and +7, they are exhibited by halogens. Students, I hope you have understood the concept of oxidation numbers and how to find them out, along with the type of hybridizations they will exhibit. So if you find this video important or useful, please share it with your friends. Thank you for watching, students.